So I guess a lot of you have seen some of all this stuff earlier this week. Yves LeBlanc gave some presentations about the AB SCIEX Triple TOF 5600 that were launched at ASMS this year. The other new thing that AB SCIEX that we have this year at CPSA is our name, our company. And I think that's really important because I'm in support of the organization. I've been with AB SCIEX, Life Tech, Applied Biosystems, PE Biosystems, PE SCIEX, going back about 13 years now. And all the time before that, we were always a joint venture between Applied Biosystems in some form with Perkin-Elmer or with Life Tech or whatever, and SCIEX up in Toronto. But this year in February, we actually were bought out by a company called Danaher, which bought both the Toronto facility, the R&D part, SCIEX, and the mass spec business from Applied Biosystems, and joined them together. So we're really just one company now, and I think that's really great because we're not a joint venture, so we can all be together, and we all actually have the same emails, which is important. So the Triple TOF 5600 is really great, and it fits into this whole quant-qual theme that we had last year and then continued into this year at CPSA. And it really is the best of both worlds, and it kind of fits the qual-quant theme by its name because it combines a triple quad, which is basically all of the features of the front end of our 5500 series triple quads, which has the industry-leading Turbo V source. It has the Q-Jet ion guide technology. It has the LINAC collision cell, all great features of a triple quad. And then we throw that into the TOF analyzer to do all of the qualitative data. So it combines 5 features. And I always try and can't think of them, and I can never remember them. But I remember them by the sort of acronym of MASS Doctor, which is mass accuracy, resolution, sensitivity, speed, and linear dynamic range. So we combine all of those things together. We have 30,000 resolution at all speeds, and even down to around 200 AMU, that's true. Below that, around 100, 150 AMU, we're still seeing about 25,000 resolution. So what does that mean for real data? Some of the stuff Yves showed yesterday, we incubated 6 compounds at 1 micromolar. We diluted that by 4-fold. We still see the parent at about 1% of it remaining after 5 minutes, which is about 3 orders of dynamic range. But we can take and look for all the major metabolites and do XIC with high-resolution XIC windows of 10 millidaltons and find all the major metabolites, in this case of imipramine. Another example of that same data set was haloperidol was also incubated in that same set. And here the resolution is just showing you that we have basically 30,000 resolution at this 5-minute time point of the parent haloperidol. We blow that up. Our new software that we have on this instrument is called PeakView. We bring all of that in. We can also do isotope matching, isotope pattern searching, and things like that. And that's showing you the theoretical, which you can't really see the colors here. It's blue and red. But theoretical compared to the experimental data of the haloperidol. And so, of course, we could always search for metabolites this way. The MSMS data, we also have high resolution on that, of course. And this is just showing midazolam, the high resolution. It was also incubated in that same series and showing everything about 1 ppm, the full mass range. And, of course, we fragment everything still in the LINAC and the triple quad part of this. So we get full coverage of the enriched product ion spectrum all the way down to mass 30 and above. How's that look in, here's in vivo data. This is a standard curve that we did in protein precipitated rat plasma. We're getting 4 orders of linear dynamic range with really good, the proof's in the pudding whenever you do these kind of things. A lot of customers have been sending this stuff to us all summer long. Let's see this in real matrix. Show us, the dynamic range. And always, of course, the CVs and accuracies is important. And this is another example of that with 65 femtograms on column, so it's 4,000 light data. And I guess I'm done.